Hello friends, welcome back to my YouTube channel. Welcome to the discussion on distillation. This is 24th part of that discussion, and since last few videos I have been talking about McCabe method. So I'll continue my discussion on McCabe method in this video as well. Today I'll be talking about feed to a typical tray column. So here you'll come to know about different types of feeds to a typical tray column. So let us start the discussion. Okay, so let us first know about a typical tray column. So a tray column is a cylindrical vessels in which trays are provided. So each tray in the column acts as a device for contacting vapor and liquid phases. That is, on each tray, the two phases come in contact with each other. Mass transfer occurs between them, and then they are separated. And while they are separating, they are close to equilibrium. So feed is admitted in the column on a tray that is located more or less at a central position. That tray is called the feed plate. So feed could be of different types. The liquid portion of the feed will be coming down, and it will be taken out at the bottom and then sent to a reboiler where it will be heated to produce the vapor phase. And the resulting vapor phase is admitted at the bottom of the column. Then it rises through the column and is taken out at the top. It is sent to the condenser where heat is removed from those vapor to get a condensate. The condensate is divided into two parts. One is taken out as the top product, or we also call that as distillate, and the other fraction is sent back to the column as reflux. Then reflux comes down and joins the liquid part of the feed, and the process continues. From the reboiler, the bottom product is taken. Bottom product is taken out. We also call that as residue. Then the feed plate divides the column into two sections. The section above the feed plate is the rectifying section, and the section below the feed plate is stripping section. Why these two sections are called as a rectifying section and stripping section, I have discussed this concept in one of my previous video. You please go and watch that video. So this is how a typical tray column will be working. And today we are going to know more about the feed that is given to the feed column. We are going to know about the types of feeds that are given to a typical distillation column. Okay, so let us know about the different types of feeds to a typical tray column. The types of feed. Now the feed to a tray column, it can be introduced under a variety of thermal conditions. By thermal conditions, we mean the energy content in that feed. Okay, so that's why I'm saying feed to a typical tray column, it can be introduced under a variety of thermal conditions, and that is the basis of classifying on those feeds. Okay, so the feed types, they are based on its thermal conditions, as I said. So what are these types? One is you have the feed may be a cold liquid. We will know more about it. Or it could be a liquid at its bubble point. We call that as saturated liquid. It could be partially vaporized feed, where it would be a mixture of liquid and vapor phases. Then the feed could be a vapor that is at its dew point. We call that as saturated vapor. It could be superheated vapor, the fifth type. That means there are 5 different types of feeds to a typical tray column. First is cold liquid. Second is liquid at its bubble point, that is saturated liquid. The third type is it could be a partially vaporized feed. Then you have the fourth type. The feed could be entirely vapor, that is at its dew point. We call that as saturated vapor. And the fifth type of feed, it could be a superheated vapor. Okay. Next, we are going to know more about this 5 types of feeds. We are also going to understand what happens, what action occurs on the feed plate as each one of this feed enters the tray column. Okay, so first let us talk about the first type. It is cold liquid, feed as a cold liquid. So in this case, if feed is a cold liquid, that means it is at a temperature well below its bubble point. As you know, feed to a typical tray column would be a liquid solution, and it will not have a sharp boiling point. Rather than sharp boiling point, it would be having bubble point. Okay, so when feed is a cold liquid solution, then it will be at a temperature that is well below its bubble point. The temperature at which the boiling process starts, bubble point. Okay, so cold liquid will be at a temperature well below its bubble point. When such a feed is admitted on the feed plate, what happens? First, it will cause some vapor that is leaving the feed plate to condense. Okay, so due to low temperature of the feed, and when it gets admitted on the feed plate, it will be coming in contact with the vapor that is leaving the feed plate. And due to this contact, some part of the vapor that is living in the feed plate, it will be condensed. Okay, so first thing that happens when a cold liquid enters the column, it causes some vapor leaving the feed plate to condense. And the condensate that is formed in the process, what happens? This condensate gets added to the liquid in the stripping section. So the condensate, which will be a liquid, it will be adding to the liquid that is there in the stripping section. So this can be represented with the help of this simple schematic diagram. So let us say this is the tray column, and now I'm showing the feed plate. So this is the feed plate, and we just know that the section of the column above the feed plate is rectifying section, and below the feed plate it is stripping section. Okay, so let us see what happens. Now cold liquid is entering as the feed to the column. So the liquid, it will be going down, it will be slowing down to the reboiler. Okay, then the liquid, due to reflux, it will be coming from the rectifying section, it will be coming to the feed plate, it will be getting added to the liquid feed, and then it will be coming down and it will be getting added to the liquid feed. Then the vapor phase that is rising from the stripping section, it will come to the feed plate, and as it rises from the feed plate, what is going to happen? Due to low temperature of the feed, some portion of the vapor, it is going to get condensed, and the condensate will be adding to the liquid that results in the stripping section. Okay, so likewise, you have liquid in the stripping section, we denote it by L bar, and this is according to the assumption of equimolar overflow and vaporization. The simplifying assumptions made in McCabe Thiele method, where liquid flow is same throughout a given section. That is, liquid flow will be same throughout the rectifying section, and it will be same at a different value in the stripping section. So we are saying that liquid flow in the stripping section is L, molar liquid flow, L, and molar liquid flow in the stripping section is L bar. Similarly, molar flow rate of vapor phase will be same in a section. In stripping section, it will be same throughout that section. We are going to denote that by G bar. And similarly, it will be same throughout the rectifying section, and we are going to denote that by G. Okay. So by looking at the diagram, you can now easily understand that if you compare L and L bar, you can easily tell L bar is greater than L. Whereas in case of vapor, since some of the vapor is getting condensed in the rectifying section, so molar flow rate of vapor in the rectifying section will be less than that in the stripping section. So the relation is L bar, that is, let me first erase it so you can understand. Now you know what is stripping section, what is rectifying section. Okay. So since it is very much clear from this diagram, L bar is greater than L, whereas G bar is greater than G. Or you can say G is less than G. Okay. So this is how conditions change when feed entering the column is a cold liquid. And you should remember this relationship. When feed is cold liquid, L bar, that is liquid flow in the stripping section, is greater than the molar liquid flow in rectifying section. Whereas the molar vapor flow rate in the stripping section is greater than the molar vapor flow rate in the rectifying section. Okay, now let us look at the second type of feed that we listed, and it is a liquid at its bubble point. A liquid which is on a verge of boiling, and that is feed has a liquid at its bubble point. We also call that as a saturated liquid. So feed at its bubble point or liquid at its bubble point is same as saturated liquid. So you can tell the second type of feed is liquid at its bubble point or saturated liquid. Okay. So when such a feed is admitted on the feed plate, what happens? It simply gets added to the liquid in the stripping section. Whatever is the liquid that is coming into the column as the feed, it will be getting added to the liquid in the stripping section. That is the only thing that is going to happen. So here there will be no condensation of the vapor phase because the liquid is at its bubble point. It is not cold enough to cause condensation of the vapor phase. Okay. So you can show that schematically again. So you have the feed plate and then the rectifying section, stripping section. Now saturated liquid or liquid at its bubble point is entering the column as its feed. So it being the liquid, it will be simply getting added to the liquid in the stripping section. Liquid from the rectifying section, it will be coming to the feed plate and then it will be moving to the stripping section. So in the stripping section now you have two liquids, you can say. One is due to the feed and the other one is liquid that is coming from the rectifying section. Liquid in the rectifying section, you know, it is due to the reflux. Okay. Whereas the vapor that is coming from the stripping section, it will be going to the feed plate and then it will be rising from the feed plate. And nothing is going to happen with the vapor. Okay, so now you can see from the schematic diagram, here L bar is greater than L because to L, feed gets added. That's why L bar is greater than L, whereas there is no change in the vapor phase. So vapor flow in the stripping section is equal to vapor flow in the rectifying section. So that's why you have this relation. L bar is greater than L. Why it is so, you can easily understand over here. You can easily understand from the schematic diagram. Whereas as far as the vapor flow is concerned, vapor flow in the stripping section is equal to vapor flow in the rectifying section. This is true when the feed to the column is a liquid at its bubble point or it is a saturated. Okay, so let us move ahead. The third type of feed is partially vaporized feed. That is, it is a mixture of vapor and liquid phases. So partially vaporized feed is nothing but a mixture of liquid and vapor. So when such a feed is admitted on the feed plate, what happens? A simple thing. Liquid portion gets added to the liquid in the stripping section and vapor portion gets added to the vapor in the rectifying section. So, okay. So liquid fraction of the feed, it gets added to the liquid in the stripping section, whereas the vapor fraction, it gets added to the vapor in the rectifying section. And you can now easily understand this with the help of the schematic diagram. You have the feed plate. Now, feed is partially vaporized feed. It is entering the column. So liquid portion of the feed is going down to the stripping section, whereas the vapor portion of the liquid is going into the rectifying section. Okay. The other things, as usually, liquid will be coming from the rectifying section and then it will be moving to the stripping section, whereas vapor, the liquid in the stripping section, it will be addition of the liquid portion of the feed and the liquid that is coming from the rectifying section, and this is L bar. Whereas in case of vapor, it will be coming from the stripping section to the feed plate, then it will be rising from the feed plate and it will be to this vapor. The vapor portion of the feed is getting added, so that the net vapor flow in the stripping section will be addition of this vapor fraction of the feed and vapor that is coming from the stripping section. So this will be G bar. Okay, now you can easily tell the relationship between L and L bar and G bar. So as far as L and L bar are concerned, you can easily understand that L bar is greater than L. So in this case, L bar is greater than L, whereas this is not G bar. This is simply G. Just a minute. This is G. And what can you say about G? G bar is less than G, or in other words, G is greater than G bar. Why? Because vapor fraction of the feed is getting added to the vapor stream. Okay. So when you have partially vaporized feed, this is what happens on the feed plate. And this is the relationship between L bar and L and G bar and G. It is liquid flow rate in the stripping section and liquid flow rate in the rectifying section. Vapor flow rate in the stripping section and vapor flow rate in the rectifying section. Okay. So I hope the concept is clear to you. If you have any doubts, you please mention your doubts in the comment section. Now let us move on. Now let us talk about the fourth type of feed, that is vapor at its dew point. You also call it as saturated vapor. So saturated vapor or vapor at its dew point means the same type of feed. Okay, so what happens when saturated vapor is admitted on the feed plate? Because now it is just vapor, all the vapor will be getting added to the vapor, that is vapor in the rectifying section. When you have vapor at its dew point, it is entirely vapor. There is no liquid part in it. So all of the vapor will be going and getting added to the vapor that is there in the rectifying section. Okay. So you can easily show the schematic. You have the tray, that is feed plate, and then you have saturated vapor that is coming now into the column as the feed. It is entirely vapor. So the entire feed will be getting added to the vapor in the rectifying section. The liquid from the rectifying section will be coming to the feed plate and then flowing down to the stripping section, L bar. Okay, so this is L bar, as you know. Okay, whereas the vapor flow, vapor that is coming from the stripping section, it will be coming to the feed plate and then leaving the feed plate, and then it will be getting added to the saturated vapor, which is the feed in this case. And the addition of this two will be the vapor flow in the rectifying section. Okay. So from the schematic diagram, now you can easily establish relationship between L and L bar and then G and G bar. So in this case, L bar will be equal to L, that is liquid flow rate in the stripping section is equal to liquid flow rate in the rectifying section. But liquid flow rate in the stripping section will be less than liquid flow rate, vapor flow rate in the rectifying section. Vapor flow rate in the stripping section will be less than vapor flow rate in the rectifying section. That is, G bar is less than G. And now you can easily understand. In G, there is addition of the vapor due to the feed. Okay. So when feed is vapor at its dew point or saturated vapor, it is going to get added to the vapor in the rectifying section. And that's why you have these two relationships between L bar and L and G bar and G. Okay. Now let us talk about the last type, that is superheated vapor. Now what is superheated vapor? It is a vapor at a temperature greater than its dew point temperature. So when the temperature of the vapor is greater than its dew point, it would be superheated vapor. When superheated vapor is admitted as a feed, then what happens? It being entirely the feed will be vapor. So all of the vapor will be getting added to the vapor in the rectifying section. Plus, due to its high temperature, it is going to cause some liquid in the rectifying section to vaporize. And the resulting vapors, they will be getting added to the vapors in the rectifying section. Okay. So superheated vapor, it is entirely vapor. So when it enters the column on the feed plate, all of the vapor will be adding to the vapor in the rectifying section. Plus, due to its high temperature, it will be causing some portion of the liquid in the rectifying section to vaporize, and the resulting vapors, they will be getting added to the vapor in the rectifying section. So the schematic is very simple. You have the feed plate, and now superheated vapor is entering as the feed. This being vapor that will be getting added to the vapor in the stripping section, and then the liquid will be coming from the top, and it will be going to the stripping section. This is L bar. Okay, then vapor will be rising from the stripping section. It is G bar. Then it will be going to the feed plate and then rising from the feed plate. Okay. Now, due to heat of the superheated vapor, what is going to happen? Some portion of the liquid in the stripping section, it will be getting vaporized, and it will be getting added to the vapor in the rectifying section. That's why the vapor in the rectifying section will be combination of these three components, and this is G. Okay. Now you can easily tell what will be the relation between L and L bar, and then G and G bar. In this case, L bar will be less than L, because in the rectifying section, some portion of the vapor is vaporized, whereas G bar will be less than G, or in other words, G will be greater than G bar. Okay. So this is what happens on the feed plate if superheated vapor is admitted as feed. Okay. So with this, I end my discussion on all the types of feed to a typical tray column. So now we know what are different types of feed to a typical tray column, and what happens when each of these feeds enter on the feed plate in the column. So for now, thank you for being with me. I hope you're watching my videos, you're liking my videos. If you have any feedback to give, you please give that in the comment section. If you have any doubts, you please mention those in the comment section. Thanks for watching my videos. Hope to see you soon in my next video, where I'll be continuing my discussion on the present topic, that is McCabe Thiele method. Do subscribe to my channel. Tell your friends to subscribe to it, and hit the bell icon so that you'll be notified as soon as I upload any new video. Have a nice day. Bye bye. Take care.